Well, welcome to the lab on atomic absorption spectroscopy. You will find that lab in your general chemistry lab manual under the atomic absorption spectroscopy. I expect you to be able to read that on your own, but I'm going to go ahead and go through the procedure that we have here. Now, I will tell you one thing. I went ahead and pre-made the 0.1 molar nitric acid solution. That is already made, and I have readily right here some deionized water so that I'll be able to make my solutions a little bit more quickly and spend a little bit less time than I would normally in the lab. So I've done a little bit of the preparation beforehand, but overall you're going to see everything that we're doing. Now, in order to understand this, you need to see here, this is the iron standard that we are going to be using. I don't know if you can read that on there, but if I bring that up, I think you can see what it is. And it is an iron standard, and it's 1,000 milligrams per liter, okay? And it's going to be plus or minus 4 milligrams per liter. And your first part of your analysis says, all right, so you're going to have to figure out how much commercial standard we need to make 10 milligrams per liter of standard. Well, it's pretty simple. I'm not going to go through the calculations with you right now. You should be able to follow along with those. But I'm going to take 1 milliliter of this iron standard. Now, normally I wouldn't just be sticking things into an iron standard, but this is a sterile and clean pipette tip, and I have it set to bring out 1 milliliter, also known as 1,000 microliters. And I am going to take that. And here I have my volume, not very well. I'm going to try that again. And actually get it into the liquid this time. And there we have our 1 milliliter, which I have then entered into my solution. And I know you guys like taking squirt bottles and dropper bottles and everything. So I went ahead and got a squirt bottle of deionized water. But for the most part, I am going to take and pour this water in here until I get close to the top. One of the things that we're going to need to do is to be able to cover this with parafilm in order to get that more precisely. And the other thing we need to do is label this. So just like you're supposed to have in the lab, I have a handy dandy Sharpie along with a flower on it so I don't lose it. You know me, I set things down and I look all over the place for them. But this is going to be a 10 milligrams per milliliter solution. I've labeled it with 10. I haven't finished completely filling it, so I am going to fill that up there. And I've got it right at the line. Exactly. So that is 100 milliliters. So I've added 1 milliliter to this of the standard solution, and I have filled the remainder of it with water to that. Now I need to take and I need to cover that with parafilm and mix that well. Okay. So I'm going to step off, grab the parafilm, cover it, and mix it. So just be patient with me here. I actually set the parafilm on the other side of the room when I was planning on doing it there. And then I discovered that the nice sun that we have in here is giving us some really weird reflections if I do it on the other side of the lab. So I'm like, oh, well, I can move to this side of the lab. That's not a problem. But I left my parafilm over there. So I remove my parafilm here slowly. Cover that well, and I'm going to invert it a bunch of times. Now, as I am doing this, I'm also going to be talking about the next thing that we're going to be doing. So remember at the beginning of the semester, we took iron tablets, 65 milligram iron tablets, and we determined the iron content of them. We're going to repeat that with this lab, but we're going to do it a little bit differently. We're going to do it using atomic absorption spectroscopy. Okay, so I am going to start by taking my iron tablet and weighing it. And hopefully here, I am going to tear this, and hopefully I am going to have this to where you can actually read this. I will say the readings out loud, but hopefully you can read what the balance says. And I'm going to start by putting an iron tablet on there. Here is our iron tablet. Okay. So as we see, it says 0.313 grams. I'm going to write that on the board. That is the mass of the iron tablet. Okay. And in that, we should have about 65 milligrams of iron. Now, in order to evaluate the iron tablet, I'm going to have to dissolve that. But in order to dissolve it, I need to crush it. So I am going to put it in our handy dandy mortar and pestle, and I'm going to crush it. Now, one of the things that I need to do with this is not just crush the iron tablet, but some of that iron tablet might get stuck here in my mortar and pestle. So I only need to, I'm going to have to take into account how much of the iron tablet I get in there. So I am going to take a new, well, not new, but clean volumetric flask, clean dry volumetric flask. I should be at 0, so I'm going to re-zero that, since every time I move my balance, I'm going to need to re-zero it. And I'm going to need to re-zero it. There we go. And when I weigh that, I find that my graduated cylinder has a mass of 63.602 grams. Writing that up. That's not a cylinder. That's a volumetric flask. Sorry. Okay. Yes, it's late in the semester for me too. All right. Now I am going to take and I am going to transfer this powder into the flask, as you see here. Now, some of you may think, is he going to spill some of that? You know, I might. I might even spill some of that on purpose, although I wouldn't do that on purpose in this lab. And when I do that, I find that I can now determine the mass of the iron tablet that I got in there. Now, I intentionally did this a little bit sloppy. Notice that it is now 63.888 grams. Okay. And if you do a little bit of math, you can see, oh, it looks like he lost a little bit of the iron tablet. Yes, I did. You get to deal with those calculations in your report. Maybe I did that on purpose. Now, when I do this, I'm going to dilute this with my nitric acid. And I've just figured out, hey, I made a mistake. I used deionized water before. I shouldn't use deionized water. I should do all of my solutions with the nitric acid. We're going to put some of that nitric acid in there, and we're going to say, oh, this drawer really messed up. This, while it was made correctly, was not made with the nitric acid. Just so happened to have another one here. And we are going to take another 1 milliliter. Now, in case you're wondering, did I make that mistake on purpose? I'll let you decide that. You might recognize a little bit better technique this time. And in this one, I am going to label that again 10. Parts per million of iron. As you can see that, I am going to dilute it with my solution. And I am going to be very precise on this. Okay, maybe not. Now, I hope the sound comes well through this. I am using one of my laptops from the lab because that's what I have available in order to film this. Let me get this to where you can see it. You'll also be able to see the data in the background here in a moment. And I am going to pour this just to prove that I can actually fill right at the line. Just perfect. Okay. Again, covering that with parafilm. I am going to mix that. And this is now my 10 parts per million properly made solution. So I'm going to leave that here where we can see it. Now we're going to need that. Now I'll probably mix it up a little bit more before I use it. You might also recognize how I have this iron tablet here. And this iron tablet has a bunch of cloudy stuff in it. Now, is that all going to dissolve? Probably not. There's other stuff. If I look on the bottle, I am going to see that there are ingredients. You know, I've got dried ferrous sulfate, but I also have things like vegetable cellulose. That's not going to dissolve. Okay, so I'm going to have some things in here that don't dissolve. I am again going to fill that to the top and then mix it well. I'm also going to let it sit to the side while I do some other mixing, but we'll come back to that. And this is our iron tablet. So here you see the iron tablet. We will come back to that. Notice I haven't filled it the rest of the way with the nitric acid. We will come back to that. If I leave it sit here, it will dissolve a lot better. Now, in the meantime, I need to make 4 solutions that are in the range. Now, normally, when I first started doing this, we had this nice AA spectrometer, and it would easily measure out a 10 milligrams per milliliter solution, or a 10 part per million solution. The one that we have now has 5, so I'm going to have to take this and I'm going to have to make a solution that's diluted down to 5. Now I'm going to do a 1, a 2, a 4, and a 5. In case you're wondering why I picked those, because I picked a 1, a 2, a 4, and a 5. Now I am going to use a clean tip to this. And in order to do a 1 part per million solution, I will need 1 milliliter of 10 and 9 milliliters of water. So I'm going to label these now here. 1, you'll see the 1 there. 2, 2 here. 4, and 5. Now, how am I going to get 1 milliliter in here precisely? I'm going to use my handy dandy pipette. I'm not going to worry about doing it super well. I'm going to try to give you data like a normal freshman class would get. Some of you do a lot better than I do. I'm going to try to get this to where you can see these. Hopefully, I won't actually put it onto my computer. I guess I need to put them further away to see them. Okay, so in the 1, I am going to take 1 milliliter of my solution. In the 2, I'm going to take 1, 2 milliliters of my solution. In the 4, 1, 2, 3, 4. Again, notice I am trying to do all the care that a normal freshman class is doing it. 1, 2, 3, 4, 5. Okay. I now have my solutions. I need to add to them some of the nitric acid. And I am going to do this a little bit carefully here. I'm going to pour a little bit here. And then I will finish off by using my pipette. Since I have that pipette tip already, I will probably use that to finish it out and to get it to the lines. See if I can do this without spilling or making a mess. And the answer is probably yes, but I might make a mess anyway. Okay. Then using a clean tip here, I'm just going to use this because I happen to have it ready. Is it the best piece of equipment to use? No. Is this the piece of equipment that I have ready to go? Yes. Right there, bottom of the meniscus. Same thing here. I will need to parafilm each of these and mix them well. I will probably do that off camera. But I will let you see the making of each of these solutions. I thought about doing this with a time lapse, but I don't think that's going to work so well. Okay, now I have my solutions as well as my blank solution. I'm going to need those when we go over to the AA. I will parafilm and mix these, but I'll come back to that here in a little bit. In the meantime, we need to go back to our iron solution. Now, if I did this correct, now I'm going to just throw out a number. And let's say, just for example, that this would have 65 milligrams of iron in 100 milliliters. How would I get that crazy number? Well, if you look at the bottle, you will see that it's a 65 milligram iron tablet. And if it's 65 milligrams in a liter, that would be 65 milligrams per liter. But it is not per liter, it's in 100 milliliters. So it's 65 milliliters in 0.1 liters, or 650 milligrams per liter. I am going to dilute this down, okay? And I am not going to tell you what the final concentration is going to be. It should be mixed up fairly well. I will need to mix it up again after, and the nitric acid. But I will tell you the quantities that I am going to use, and you will need to be able to use that to do your calculations. Now again, this is not the best piece of equipment to use for this, but it's something that I have readily available that I don't have to clean up afterwards. So I am going to do this in the midst of this fun coronavirus quarantine. There we go. Just perfect. All right. Now, this is my 650 milligram or so. You probably can do some calculations. In order to get to this range, I am going to take a half a milliliter of this, and I am going to dilute that into 100 milliliters. Okay, so with that, I am going to pause for just a second, get these little solutions mixed up, and you will have just a pause in the recording. Okay, we are back. I went ahead and parafilmed and mixed up these solutions, but we're going to have to go over into the couple minutes. Right now, I am going to take, this is a well-mixed iron tablet solution. I'm going to take 1 milliliter of it. Oops, probably should use a clean tip for that. Just so happen to have a clean tip handy. I might have planned for this. Helps if I reset this. So I'm going to reset this down to 0.5 milliliters. Okay. Add our iron solution. Sorry, not our iron solution. Our nitric acid to our iron solution. Diluting it. Now, in general, it's a good idea to go ahead and mix it up some before you filled it up all the way. That way you don't have to invert it quite so many times. Makes it a little easier, although you can wait till the final time and just deal with it. And let's see how good I am with this one. I guess I put it to where you can't see it. I will again bring it here. Let's see how good I am. Should I go over a little bit just for fun here? Yeah. Okay. So that's pretty good. All right. Not perfect. Again, I'm trying to give you real data. So if you do an analysis of this lab, you might notice, oh, hey, this isn't going to be perfect. Mixing this up well. So now I have a diluted iron tablet solution. If I run this through my AA, it's going to cause problems. That's going to be a little bit too tight. This is my solution. I am going to need this as a blank. This is the solution from which all my other solutions were made. I'm going to run this through the fire to make sure that I know how much of the light that is absorbed is just from this solution. Everything else is going to be from the iron. I have my iron tablet solution and my 1, 2, 4, and 5 milliliter solutions. With that, I'm going to go ahead and pause, and we will go across to the atomic absorption spectrometer. I'm going to take one last moment to make sure that you can see this. There you can see the iron tablet. There you can see the dilution that we did with the iron tablet. And there you have the mass of the flask and the mass of the flask plus powder. Right now, I'm going to go ahead and light the flame absorption spectrometer. I'm not going to go ahead and go through all of the adjustment with you here. Okay, we'll come back to that. In troubleshooting, it helps to light it if you actually turn the fuel on first. And there we have our flame. I'm going to go ahead and do a few adjustments to the machine before we take our measurements, but I'll do that while we're paused. Okay, I have tried to play with this a little bit and get where you could actually read the numbers and see what's going on, but instead I'm going to go ahead and read these to you. The first thing we're going to do is we are going to calibrate this with just some of the 0.1 molar nitric acid, and we have that. Now I could do a couple things here. Right now I have this at 0, so it's set at 0, and we are going to start measuring some of these with the 1. Just a second here, I've got to make one little adjustment. Okay, so again, I think I paused it when I meant to be collecting data. So we're going to go ahead and do this again. The iron, if I measure it, I'm going to find that it ends up at a 0.073. The 5 is going to measure at a 0.180. The 4 measures at 0.130. The 2 measures at 0.065. And the 1 measures at 0.031. As we can see, our iron is definitely within that range. I will go ahead and take a look at the video and see if I need to edit it or whether we're good where we are. In either way, I will go ahead and add the data on another screen here in just a couple minutes. So again, here it is, the solution and the concentrations and the absorbances that we have. Notice you should have more significant figures on that, but those should be pretty accurate there. This is the data that you're going to need in order to make your graph. And with that, I hope you have enjoyed getting to at least see the lab that we're doing in this class. I will be adding a little bit of discussion to a separate video that I will post about this one, but this will complete the lab for the semester. I hope it goes better in the fall and we are able to be back together in person. With that, I will see you all later.